So let's start with the first ray diagram of image formation. The mirror that we are using is concave. The position of the object, first we'll begin with at C. That is, we'll keep the object at C. So that's your C, this is your F, and this is your P. So the question is, where is the and how is the image size and so on and so forth. For that, we need to draw the ray diagram. Again, I would like to make you guys understand this. This is an object with a light source. And this light will emit in all the possible direction. You guys need to understand that. So out of this, all the possible light ray, we have to choose two of it. I can choose a ray parallel, falling at the focus, going through center of curvature, but whichever is practical, that you guys have to choose. So choosing a ray which is parallel is traditionally what is done. So this will bounce back in this manner, right? So this is what we have to indicate. This is a object, and from this tip I could have taken any place, but I took the tip. It's convenient. I'm considering a ray which falls parallel to the mirror, and we know that any ray parallel to the mirror will pass through the focus. Next ray I will consider is going through the focus, and this too we know that it will be parallel to the principal axis. Okay, so my diagram is actually wrong. I didn't get a good diagram. The answer is actually the image should be formed at the center of curvature itself. This is one thing that you guys can manipulate. That is, we know the answer before doing the ray diagram. Okay, so here when we keep the object, right, position of the object is at center of curvature, the image will be located at center of curvature itself, and the size of the image is same as that of the object. So this is something that you guys have to remember. Okay, so the ray going through the focus, right? Okay, I think the focus, it should not be wrong actually. I don't know what. It should have been something like this. So that it passes through your center of, this point. Okay, so let me have a look where I did wrong. Let me redo the entire thing. Okay, that will take. Let me redo this part. With pencil and everything, I've done it right, but here I'm not getting. Again, this is not up to scale, I guess. So ray parallel. Oh yeah, this lens is not proper now. This is not in proper arc. That's why all this confusion. Because this focus and center of curvature, I've taken it right. Anyways, I'll show you the actual diagram. So this, I'm just going to show you guys rough. Okay, please don't take this as a face value. So this is where the object is, image is formed. Okay, by default, this is where it's formed. This is a wrong diagram. Again, I'm warning you guys. This arc is not that good. So that's the problem. Lengthwise, everything else is good enough. But this is what, this is a wrong diagram. So main thing that you need to understand over here is, I'm considering two rays from the same point. And where the reflected ray converges is where the image is formed. Okay. So this is where the image is formed. How does it look practically? I'll show you that also. But this is what you have to understand. If I keep an object at C, the image will be formed at C and it will be of same size. Right? So what else should I tell? This is one mistake I've made. This is not supposed to be in that manner. And don't forget to indicate the arrows. So once you've done this, you need to name the center of curvature, focus, and pole. And what else? Then you can also name your object and image, A dash, B dash. So this is what you have to do. Now I'll show you guys the actual ray diagram using pen and pencil, and this you have to do. There's no escape with this. So try to do it along with me. If not, you can see once and then try to do it on your own. Any mistake, you can come back to the video, right? So let's have a look. So for very first thing is you need to draw a straight line, which I have already done. So I'm just marking a random point. That will be my 0. So then I'll mark 0, 3, and 6. So same steps. So 3 points which are 3 centimeters apart. Draw an arc. Okay. So I think I'm trying to do it darker now, extending it. So since it's a mirror, we have to indicate that it's a mirror. Shade it at one end. So now I'll pick up the center of curvature and draw the object. Okay, I overdid it, then I'm erasing. Not a good thing. Anyways, try not to erase too much, but since that was initial and that was part of the mirror which I won't use, so I kind of erased it. So here you need to notice that I'm drawing an object of size 1.5, and at the other end I'm marking 1.5 as well. So since I know the answer, I'm able to do this. See, when the object is at center of curvature, the image will be at center of curvature and the same size. This I'll show you practically, you'll understand how and why. So first trace, I'm drawing parallel. See, the mistake that I did over here is I actually didn't measure. I think I did. No, I didn't. So 1.5 at the other end also I had to measure near the mirror actually, so that line is properly parallel. With my experience, I done it, but yeah, you guys should not be doing that. But yes, see, I got the right answer. Again, this is because of experience. But if I ask you guys, if I had to do it for the first time, I would have taken 1.5 measurement a bit further and drawn a parallel line. Through focus, it's not a big issue. We just draw it wherever it meets, right? From there again, I need to draw a parallel line. But in this case, since I know the answer, that has to be the parallel line. So, and it is parallel. Can you see that? It is parallel, right? So principal axis and that line is parallel. So this I did it out of experience. I should have shown you guys a bit more systematic. So that's where the image is formed. Please notice that the arrow is upside down. Okay. So the arrow is upside down. The image is upside down. That is. Right. Again, try to see to that you keep this around 1.5. Easy to manage. Nothing that you can't take in any other value. So this too has to be 1.5 away. Height, in sense of height. You can take one of the points somewhere over along the line and mark 1.5 and draw a straight line to get a parallel line. You get proper answer by doing so. Again, you do it once, that's enough. There's no point in repeating all of this. Just do it once properly, right? Like how better than me if possible. Neater, right? So you have to do it all, and I'm not labeled over that because again, I wanted to show it over here. So labeling is must, and I'm showing it over here, by the way. One more thing that I wanted to tell was, yeah, I've seen people drawing image in this manner. It's not that. Since the light started over here, the light will end over there. Okay. So this is one thing that we need to understand. Okay. So I want to show you guys one more thing. It might not happen with this diagram, but I'll try. See, if I happen to take a light source from here, let us see what happens. Instead of that point, I'll take this point. So we have a parallel line passing through the focus, right? Then making it pass through the focus. Now I'll draw a parallel line. Can you see that? It started over here and it ended up over there, approximately. Again, not done a good job, but approximately ended over there. So what I'm trying to show you guys is you can start the diagram any point, any part of the figure you can take. The point wherein it meets, it represents that part of the object. Since I started at the peak, the point where the light converges is where the peak is. If I had taken some other point, that would have been the location where that part of the object is located as an image. I hope you guys understood that. Okay. So there are a few more things. Orientation. Orientation is it's inverted. Is it real? Yes, it's real. It can be captured on the screen, which I'll be showing. So how can I use this kind of setup? And they'll ask you, how can we use this setup? You can use this setup to find the focal length and radius of curvature of a given concave mirror. Okay, so we can make use of this setup to find the focal length and the radius of curvature of a given concave mirror. I'll explain how. So first we'll see how I do it practically. So please have a look. So let me explain what I did. Let me erase this off. See, what I did was I fixed the position of the object, and I knew a sharp image will appear at the same place. So since the object was kind of, it's a bit heavier and not so convenient to move around, I moved the mirror itself. I started moving it forward and backward. And I stuck to a point wherein I got a sharp image. So since with this knowledge, I was able to fix the distance between the object and the mirror so that I get a sharp image. That's what I did, is it not? You're able to see that, right? If not, go back and watch it again. That's what I did over there. So with this knowledge that yes, if I keep it as center of curvature, the image has to be at center of curvature, I was able to find the distance from this point to this point. I'll show you how. See, this is the photo of that experiment. So I ended up with this position. So you can see this is that cutting board we get nowadays. So this mirror, if you're not able to make out, it actually ended up at 6 centimeter on the board. And this I had kept fixed at 40 centimeter. So I just moved it from 0 centimeter and I started moving it a bit forward slowly. And I got a sharp image on the screen itself, because I know, right, when the object is at center of curvature, image has to be at center of curvature. I was looking for that. So since I got a sharp image, I can definitely tell that yes, this distance from 40 to 6 is my what? Radius. Because this is center of curvature and this is pole, right? This entire length has to be radius. And this turns out to be 34 centimeter. So if the radius of curvature is 34 centimeter, the focal length, which is half of the radius, will be 17 centimeter. So this particular experiment will help us find the radius of curvature and focal length. Okay, I hope you guys enjoyed this. If you guys have a concave mirror, or if you are able to get it, or it's there in school, please try doing this. Ask your teachers to do it. I'm sure they will know how to do this. So you'll see a sharp image. It's fun looking at an image, I don't know if you're able, because the quality of video is not that good. You might not be able to appreciate it that well. But yeah, it is kind of fun to look at. You can get an image of the window and cloud and all of that. I know, I like it. So I think you guys will also. Okay, so you guys have to pretty much write on all of this and also draw the ray diagram. I hope you guys have done that. So please pause and copy it off. So please make a small running note. Don't draw the entire thing. You can just make a note that, okay, radius of curvature If it's 34, focal length is half of that.